Okay, today we're diving into a world that is literally all around you, but you probably never see it. It's not the internet you use for web browsing or streaming. No, this is the other internet, the secret, invisible network of billions of smart devices that are quietly running our world. So let's kick things off with a little puzzle. Have you ever thought about this? Your super powerful smartphone, with all its tech, can barely make it through a single day without needing a charge. And yet, some tiny smart sensor can run for a year, maybe even longer, on a little coin battery. How on earth is that possible? Well, the answer to that question reveals the hidden genius behind the whole Internet of Things. To solve our battery puzzle, we first have to get one thing straight. These tiny devices simply can't use the same internet your phone does. It's not going to work. The tech that powers our high-speed, always-on digital lives is like using a fire hose to water a houseplant. It's complete overkill. So we've got to explore a totally different kind of network. When you really boil it down, the IoT world kind of splits into two basic jobs. On one side, you've got sensors. Their whole purpose in life is just to gather one tiny piece of data, like what's the temperature or is a door open, and then report in. On the other side, you've got actuators. These guys just wait for a command and then bam, they do something, like unlock a door or shut off a water valve. See? Neither of those jobs needs the constant power-hungry connection of a smartphone. And sis, right here is the absolute core of the problem. Our traditional IT world, everything we've built, is designed for power-hungry devices, like our laptops and servers that are always on, always connected. It is a massive mismatch for a little sensor whose entire strategy is to wake up for 1 second, whisper a tiny message, and then go right back to sleep to save power. So how do they pull it off? What's the secret? Well, it's pretty clever. They don't shout across the internet, they whisper. Engineers created these specialized ultra-lightweight languages, or protocols if you want to get technical, designed specifically for these low-power devices. Let's take a look at how this secret language actually works. All right, so think of it like this. On the left, you've got HTTP. That's the protocol your web browser is using right this second. It's a constant chatty conversation. Your computer asks for something, the server responds. It's heavy, full of extra data. But then on the right, you have MQTT. This is the absolute star of the IoT world. It's not a conversation at all. It's a single, super efficient announcement. And the difference in efficiency is just staggering. Look at this. To send one simple message, temp equals 70, the heavy HTTP protocol might use around 500 bytes of data. But the lightweight MQTT protocol, it can do the exact same job with just 50 bytes. That's a 90% reduction in data, and that saving translates directly into a massive, massive saving in battery life. So how does this whole publish and subscribe thing work? It's actually beautifully simple. First, the sensor, we'll call it the publisher, wakes up for just a split second. Step 2, it sends its one little message to a central server called a broker. Then, step 3, and this is key, it immediately goes back to sleep. Meanwhile, your app on your phone, the subscriber, is just listening to that broker. It gets the update, and that's it. The sensor did its job in an instant and is back to conserving every last drop of power. But, a lightweight language is only half the solution. The other half of the puzzle is the network itself. For these tiny little devices, connecting to a standard Wi-Fi network is still that sledgehammer to crack a nut problem. It's just too power hungry. So they have their own whole other set of invisible networks. You see, unlike Wi-Fi, which tries to be a jack of all trades, these networks are specialists. Each one is built for a specific job. Zigbee, for example, creates a mesh network, which is really cool. It means devices can pass messages to each other, like a bucket brigade, extending the network across the whole office for something like smart lighting. Then you have Z-Wave, which is a big favorite for smart homes because its whole promise is that everything just works together. If it's Z-Wave, it'll talk to other Z-Wave devices, guaranteed. And then there's LoRaWAN, which is basically magic. It trades speed for incredible range. We're talking miles of range from a tiny battery, perfect for smart cities or farms. Of course, Wi-Fi still has a place, but it's for the heavy lifters, like a video doorbell that needs to stream a ton of data. So, these devices are smart, they're efficient, they're everywhere, but and you knew about was coming, this incredible convenience comes with a pretty serious hidden risk. And that brings us to a legendary cautionary tale in the cybersecurity world. The story of how a simple fish tank took down a business. The danger we're talking about has a very cool name, Shadow IoT. All it means is any smart device that an employee brings into work and connects to the company's network without IT ever knowing or giving permission. It could be a smart speaker, a coffee maker, or, in our story, an aquarium feeder.
So the story kicks off with something completely normal. An employee is getting ready to go on vacation. Simple enough. They've got a little fish tank on their desk, and they just need a way to feed the fish while they're gone.
So they do exactly what any of us would probably do. They hop online, find a cheap, internet-connected aquarium feeder. Seems like the perfect, totally harmless solution, right? They bring it into the office to get it all set up.
And right here, this is the critical mistake. To get the feeder online, they connect it to the main corporate Wi-Fi network. And how'd they get the password? Oh, it was just written down on a whiteboard nearby for anyone to see. And just like that, without having any idea, they've just opened a massive backdoor into their entire company.
So here's the nightmare scenario that unfolded. That cheap feeder, it had literally zero security and a password that couldn't be changed. A hacker, just scanning the internet for easy targets, finds it almost immediately. They break into the fish feeder, which gives them a foothold inside the company's supposedly secure network. From there, they use the little feeder as a launchpad, a jump box, to attack the company's most sensitive systems, like the payroll server. All of this because of a fish.
Now that is a scary story for sure. But here's the good news. These kinds of threats are absolutely preventable. The pros have developed some really smart strategies to tame these wild, unmanaged devices and keep our networks safe.
It really comes down to two main fixes. First is something called Network Access Control, or NAC. Think of it like a super strict bouncer at the door of your network. If your device isn't on the approved list, it is not getting in, period. The other big strategy is to create a completely separate, isolated guest network, a dirty network, just for these personal smart devices. That way, hey, even if the fish feeder gets hacked, it's trapped in its own little sandbox and can't get anywhere near critical company data. Ultimately, it all boils down to this one idea. The magic of the Internet of Things isn't just about connecting everything to the internet. That's becoming the easy part. The real work, the real challenge, is in managing and securing the billions of these devices we're adding to our world every single year. And that leaves us with one last big thought to chew on. This other internet is growing exponentially. It's not slowing down. So the question for all of us is, how are we going to strike the right balance between the incredible convenience these devices give us and the serious security they absolutely demand?